Welcome to the tutorial over Lesson 4.4, Complex Numbers. Your new vocabulary is imaginary unit, pure imaginary number, complex number, and complex conjugates. Before we go into imaginary numbers, I want you to consider this equation. Y equals x squared plus 2x plus 4. And if you graph that in your calculator and you try to find the zeros, you end up getting an error. You get no solution because it happens to be above the x-axis. Okay? Well, if we think about this, it actually doesn't mean that there's no solution per se to this question. We end up getting imaginary solutions, and that's what this unit's about. So far in your math studies, you've worked with real numbers, but equations like this have led mathematicians to define imaginary numbers, and the imaginary unit I is defined to be I squared is equal to -1. And the number I is the principal square root of -1. That is, I is equal to the square root of -1. So before now, we couldn't take the square root of negative numbers. Now we can. We just know that I is equal to the square root of -1. Numbers in the form of 6i, -2i, and I to the square root of 3 are called pure imaginary numbers. So pure imaginary numbers are square roots of negative real numbers. We will get to complex numbers and complex conjugates later in the video. So example number 1, square roots in negative numbers. We're going to simplify the square root of -28. Alright, so anytime we need to take out a negative, we can take it out and replace it with I. So we can actually rewrite this as I times the square root of 28. The next thing we're going to do is we're going to actually take square root 28 and we're going to do the tree to reduce it. So I know that 2 times 14 is equal to 28. And I know that 14 can still be split into 2 and 7. And here we can actually see that 2 has a friend. One breaks out of jail. One dies. And that gives us 2i to the square root of 7. So you should remember this from geometry. If not, and you need some extra practice, make sure you ask your teacher. Alright, let's look at B. We're going to simplify this one as well. So the first thing I'm going to do is take out that negative, and I'm going to replace it with I on the outside. So we get I times the square root of 32. And then we can break the 32 down into 2 and 16. 16 can split into 4 and 4. And here we see that we have 2 pairs. One of the 4 is going to cancel. And then we can bring 1 on the outside. And the 2 doesn't have a friend, so he's stuck on the inside. So we get 4i square root of 2. And that's how you reduce those. So the only thing that's new from simplifying radicals is the fact that now you can simplify them with negative numbers, and all you do is put an I on the outside. Example number 2, we're going to simplify -3i times 2i. Now we're going to take the numbers and we're going to multiply them together, and we get -3 times 2, which is -6. And then we're going to take the two i's and multiply them together. Well, I times I is equal to I squared. And if you remember to the beginning of the video, I squared is actually equal to -1. So we're taking -6 times -1, which is 6. And that's your answer. The next one, we have products of pure imaginary numbers. Alright, so these, we need to first take the negatives out of our square root. So we're going to rewrite this as I times the square root of 12 times I times the square root of 2. Alright, so now we can take our i's and multiply them together, and we can take our 12 and our 2 and multiply them together. We get I times I, which is equal to I squared, which is equal to -1. So we have -1 times 12 times 2 on the inside, which happens to be 24. Now, we can't just leave it like that, so we actually have to do our prime factorization. We know that 2 and 12 go into it, we have 2 and 6, and here the 2's are partners. One's going to cancel, and one's going to make it out. So we have negative 2 square roots of 6 is our answer. For our third example, we're going to solve for y. Alright, so the first thing we need to do is subtract 20 on both sides. And we get 5y squared is equal to negative 20. Next thing we're going to do is divide by 5. And we have y squared is equal to negative 4. And the last step is to square root both sides. And normally we would stop here and say, oh, you can't square root a negative number. But now we have the tools to where we can. And we get y is equal to plus or minus the square root of negative 4. Now you have to remember, every time we take the square root of something now, we have to put that plus or minus there because we're going to get two answers. Well, here we can't leave the negative 4 that way, so we're going to bring the negative out and it becomes an I, and then the square root of 4 is 2. So we have y is equal to plus or minus 2i. So this brings us to complex numbers. A complex number is any number that can be written in the form of a plus bi, where a and b are real numbers and I is the imaginary unit. A is called the real part and b is called the imaginary part. So our examples here, we have 5 plus 2i, and then also we have 1 minus 3i. Okay, so this 5 is going to be the real part, and the 2i is the imaginary part. Okay, and it always has to be written in this order. The real has to be first, and the imaginary comes second. So in order to do this, we're going to set the real parts equal to each other, and the imaginary parts equal to each other. And again, we're trying to find the values of x and y that make the equation 2x plus yi equals negative 14 minus 3i true. So the way you know which ones are real and which ones are imaginary, the imaginary ones are going to have the I in them, and the real ones are not. Okay, so we're going to take 2x equal to negative 14, and we're going to take y times I equal to negative 3i. And we're going to solve each of these equations. So the first one, we're going to take 2x and divide by 2, and take negative 14 and divide by 2. And I get x is equal to negative 7. And on the next one, well, I'm going to just take each equation and divide by I. So I get y is equal to negative 3. And those are my answers. X is negative 7 and y is negative 3. So again, all you do is take the real parts equal to each other and the imaginary parts equal to each other. Example 5, adding and subtracting complex numbers. We're going to simplify 3 plus 5i plus 2 minus 4i. When you're adding and subtracting complex numbers, you can only add the real parts together, and you can only add the imaginary parts together. You cannot combine them. So we're going to combine like terms. So we're going to get 3 plus 2 for my real part, and I'm going to get 5i minus 4i for my imaginary part. And together, 3 plus 2 is 5. 5i minus 4i is kind of like it having an x. That just leaves me with 1i, so this is 5 plus I. Okay, the next one, we're going to do the exact same thing. We're going to take our real parts and add them together, and we're going to take our imaginary parts and add them together. Now before I can do anything, I have to make sure I distribute this negative. So I'm going to rewrite my equation. 4 minus 6i minus 3 plus 7i. And the reason why I did that is because we had to distribute that negative. So again, we're going to take our real parts and add them together, and we're going to take our imaginary numbers and add them together. We get 4 minus 3 for my real part, and I'm going to get negative 6i plus 7i for my imaginary. Alright, so my overall answer is going to be 1, because 4 minus 3 is 1. And then negative 6i plus 7i is going to leave me with 1i. So plus I. And that would be my answer. Example 6. In an AC circuit, the voltage E and current I and impedance Z are related by the formula E equals I times Z. Find the voltage in a circuit with current 1 plus 4J amps and impedance of 3 minus 6J ohms. So first we're going to write our formula down. And we're going to write down what we know. And we know that I is equal to 1 plus 4J, and we know Z is equal to 3 minus 6J. So now we're going to plug and check. E equals 1 plus 4J times 3 minus 6J. Now, in order to figure out what my answer is, we are going to FOIL, okay, or double distribute. So we're going to take our first terms and multiply them. We get 1 times 3, which is 3. We're going to take our last terms. So 1 times negative 6J. It's negative 6J. We're going to take our inner terms, 4J times 3, which is 12J. We're going to take our last terms and multiply them to get 4J times negative 6J, which is negative 24J squared. Now we're going to combine like terms, and we're going to take this J squared, and if we think about to the very beginning, we knew that I squared is equal to negative 1, and in this case, J is I, so we're going to say J squared is also equal to negative 1. So we're going to take this and replace it with a negative 1. So we get E is equal to 3 minus 6J plus 12J minus 24 times negative 1. So when we combine like terms, so we're going to take our J's and add them together. And then we're going to take our 3, and this actually becomes a positive 24 when we multiply. So we're going to take our 3 and our 24 and add them to give us 27 plus 6J. And here there's nothing else we can do, so we would say our answer is 27 plus 6J volts. Last thing we're going to talk about is dividing complex numbers. And this is where the conjugate comes in. Okay, so we need this to be in the form of A plus BI. And in this case, we are not in that form. So in order to put it in that form, we're going to multiply by our conjugate. Okay, in a conjugate, you have to look for your A plus BI form. And you're going to write the same expression just with the opposite sign. Okay, so the conjugate is the same expression but with the opposite sign. Now, what we do to the bottom, we also have to do to the top, because technically all we're doing is multiplying by 1. Alright, so once we do this, we're going to take 5i times 3, that's going to give me 15i, and 5i times negative 2i, it's going to give me negative 10i squared on top. And then on the bottom, when we actually FOIL, all we have to do is take our 3's and multiply them, and our 2's and multiply 2i's and multiply them, because our middle term is going to cancel out when we FOIL. That's the whole point of multiplying by the conjugate. And what that gives me is 9 minus 4i squared. 9 minus 4i squared. Now, we know that I squared is equal to negative 1. So we're going to replace these with negative 1. So this gives me 15i plus 10, because negative 10 times negative 1 is 10, over 9 plus 4, which is 13. Now, since we have just a number on bottom, we can actually split this fraction into 15i over 13 plus 10 over 13. Now, in order for this to be in the correct form, we have to have our imaginary second. So our answer is 10 over 13 plus 15i over 13. That's our answer. Our last example is going to be 5 plus I divided by 2I. Alright, so to get rid of that I on the bottom, we're going to multiply by I over I. And the reason why we're going to do that is so that way on the bottom, I squared is equal to negative 1. So let's go ahead and multiply this. We're going to distribute an I to each one of these, so we get 5I plus I squared divided by 2I squared. We know that I squared is equal to negative 1, so we can actually replace I squared with negative 1 in each of these situations. So we get 5I plus negative 1 over 2 times negative 1. That gives me 5I minus 1 over negative 2. Now, just like in the last example, we can now split the fraction. That means you rewrite the first term with the same denominator and the second term with the same denominator. So we have 5I divided by negative 2 minus 1 over negative 2. Now, these two negatives are going to make a positive. So we get negative 5I over 2 plus 1/2. Now, in order for this to be in the correct order, we need to make sure that we have the imaginary part second. So we're going to take these two and we're going to switch their places. So we get 1/2 minus 5I over 2. Thanks for watching.